Well, good afternoon again, everybody, and welcome back to another Technolive stream where we're actually going to be starting off slightly differently this week because, well, first of all, you've got me, when it's normally Jack doing the intro, which of course is already an anomaly, but also, Jack's not here this week. Jack is away doing other things this week. We'll be back next week, but for this week, we have a new guest. We have Luke here with us today from Technocamps Swansea. So, good afternoon, Luke.
Good afternoon. How are you doing?
I'm good. How does it feel to be on Technolive?
Well, I'm a big fan, so it's quite nice to actually be on the show for once.
Excellent. Excellent. That's wonderful. So, we've just gotten set up here. We're going to be doing something quite unique today. Some of you have probably seen in the title of the video. The date is wrong. Apologies for that. But we are going to be making a game with Scratch and Microbit. So this is something that we've never done before on Technolive. We've seen Scratch, we've seen Python, we've seen Gamefruit, we've seen Unity, we've seen games of many kind. But we have never actually seen a Microbit before. We have played around with Microbit software on Make Code for Microbit, but we've never actually programmed a physical, real-life Microbit and then tried to use it on Technolive before. So this is going to be a completely new concept for all of us. And Luke is going to actually guide me along and basically tell me what to do this week. So I'm going to be following Luke's instructions to the best of my ability. We're going to see what we can come up with. And I don't know how it's going to go because I'm, as you know, as all of you who are avid Technolive viewers know, I can make so many mistakes all the time and make a right hash of things. So we never know how things are going to turn out on Technolive. But we're going to give it a go. Yeah. So, Luke, what would you like me to do first?
It's a good question. So today we're going to be using a Microbit with Scratch. So from like the default, when you open up Scratch, you won't be able to immediately use a Microbit. So the first thing we need to do is actually make sure that the Microbit is connected to the computer. So hopefully this goes without any hitches when we get this set up on your device.
Hopefully, yeah.
So are you on a Scratch screen? Opened up a kind of a new Scratch project.
I can do this. Can I use the online version?
Yep, the online version will work great.
Well, that's wonderful. I will change let me just quickly flick over here so that everyone else can see it.
Are you on?
There we go. Okay, and hopefully that should catch up on the stream now. So I'm on a new Scratch screen and I'm going to create a new project. So I clicked on that create button in the top of the screen and I am now on a new Scratch project.
Great. So the first thing we want to do is on the left where we've got our blocks palette, so all the different coloured blocks and the different kinds of blocks, we need to add in new kind of functions that are specific for the Microbit so that we can actually use it in our game. So right at the bottom, underneath all the colours and all the blocks, there's a blue button which has a little plus symbol on it.
It does.
So if you click on that, this allows you to add an extension. And Scratch has many kind of extensions that you can add to it by default. And you want to be finding one there called Microbit.
I have got that one. Okay, it is there.
So once you've clicked on this, something should pop up. Now,
it does, yeah.
It probably looks different on mine to yours because I've already got it set up. But I imagine it's maybe searching for a Microbit.
It is trying to search for a Microbit, but it is having some problems trying to find it because I haven't actually got mine turned on yet.
Okay.
So, let me dig out my Microbit. I've even kept it in its little box, in its little foil bag.
That's good.
Yeah. It is. I'm impressed with myself for maintaining my equipment as well as I do here. Except my PC is obviously covered in dust and is, but my Microbit is safe.
That's
inside
good.
This little box. Right, my Microbit is plugged in. to its little battery pack. Does it need to be in a battery pack, or does it need to be plugged in with its USB-C?
It connects via Bluetooth, so it doesn't need to be plugged into the computer.
Okay.
But something you will probably have to do, because I'm assuming that you haven't put a program onto the microbit yet, is in this window, it probably won't connect by default. It
is saying make sure you have Scratch Link installed and running. Check that Bluetooth is enabled.
So we need to click on, I think there's a help button or something
There
like
it
this.
is.
It'll take us to a page.
Yep, got it. And I need to install the Scratch Link.
Yep, so that's a very small bit of software that just allows the kind of the Scratch editor to talk to the microbit through the Bluetooth.
Okay, I'm having to quickly grab it from the Microsoft Store, so I will be... There we go. Grab that. So, if any of you are using something like a MacBook or something like that, you might find that it is slightly different to the way that it directs you. So I'm on a Windows PC today, and it's asking me to go via Microsoft to get and via the Microsoft Store to download Scratch Link. You might find that there's a more direct way of doing it if you're on MacBook, but it'll vary. But it should be quite straightforward. You can get it from the App Store, or you can get it by a direct download. But I have successfully installed Scratch Link.
Okay, and then the next step is that it provides on that website, the same site, a hex file. So that's the kind of program that a microbit can actually run. And you want to download that and then transfer it onto the microbit itself.
Okay, I can do that. So I'll need to plug the microbit into that.
Oh yeah, I forgot about that.
So
that's the one step I forgot about.
I am plugging in my microbit. I will pull its little battery pack out so that it's a bit easier to maneuver. There, I am plugging it in. Microbit is successfully plugged in. There it is. Some of you probably got the Windows. Dun, 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 dun.
That's a very good impression.
I'm quite proud of myself for that one.
Yeah, a new talent.
Yeah. Right, it is plugged in. So let me have a look. Okay, so I've got my microbit, and I need to drag and drop that hex file onto my microbit.
Yeah, and you'll see when you do that, the microbit has a light on the back that will start flashing when it's transferring.
Yep.
And then once it stops flashing, that means that it's completed the transfer.
It is on there.
And you'll see a word start scrolling across it, I think. And I think it's a random word.
Well, what it's doing is it's still running... Okay, I don't think it transferred quite correctly, because I think it's still running my previous program.
Oh dear.
So we're going to try that one again. Yeah, it's still running the previous program. Let's try that again. I will remove set. Does it need to be unzipped? This is why. It's still inside of a zip file.
Oh.
I need to unzip it. Extract all. Yeah, just keep it in downloads.
That's interesting. So it didn't do that on the Mac version. I did it earlier. It just downloaded the exact file needed, the hex file, and then dropped it in. So
interesting.
That's interesting.
Okay, it's now transferring the actual hex file onto the microbit, and not the zip file.
Let's hope it coped with having a zip file chucked at it.
There we go. We've got a word. Yeah, it seems to have survived. I've got a word. It says... I don't know.
It's a random string of letters, 5 characters usually.
Yeah. There we go.
So now if you look at your Scratch editor, and you've got Scratch Link turned on, because I think you download Scratch Link, but then you have to actually run it as open the application.
Mm-hmm.
And then it should have a microbit there with that random 5-letter characters there, so you know which one is yours.
Right, it is looking for the device. Select your device in the list above. Okay, all the microbit is currently doing is displaying the letters and numbers and then a sad face.
Oh. It's not meant to have letters and numbers and a sad face.
Oh no. Okay, no device is found. Okay.
I'm thinking that didn't transfer properly from the program.
No, I don't think it did. It's looking... I'm going to give it one more chance to just look for devices. So we're back on looking for devices. And it says 504 sad face.
That sounds like
Oh,
an error
it's an
code.
error code.
Yes.
Wow.
I wonder what that error code means. So I think try transferring it again.
Yeah, I think so. Maybe it didn't like that zip file. Right, let's just try it again. Transfer microbit go. Okay, it is transferring the hex file again. It is doing it. The orange light is flashing. It is still copying. It has copied. Okay. Right, now it has the same random letters again, which is good. Refresh.
Is there an error?
Not got an error. I've clicked refresh on the Microbit website, so it's looking for devices. 9T. Still looking for devices. No devices found. Okay.
Maybe I would try refreshing the editor and going through the steps on Scratch again.
Okay, good idea. The error code has come back.
This is going well, isn't it?
It is. As it's true Technolive form. So it's all going well. Okay, not to worry. What we'll do, hang on a minute. Might be because I'm not. Maybe I should just. Oh wait.
Is your Bluetooth turned on? Is another thing I'm thinking of. But
On my oh. Where's oh dear. The Bluetooth that I have is not built into my computer and is done off of a tiny little dongle.
oh, okay.
So I will need to plug that in. This is fine.
It's interesting that you keep getting an error code on the microbit, though. I'm not sure why that's happening.
Right, the Bluetooth is in. My Bluetooth is in, and I've moved just the hex file onto the microbit. It's now displaying the things connected. I've got it.
Yay!
We're there.
Okay.
Right. Connect.
So we can connect the microbit.
Microbit is connecting. Connected.
Yay!
Yes.
Okay. I was worried I'd have to take over and just do it myself there.
We're there now.
Great.
Okay.
Now what were we going to do? Now that that's out of the way. Cool. So what we're going to try and make today is we're going to make a game where you're a pirate and you've forgotten where you buried your treasure. Because it's been a while since you buried your treasure. So
Okay.
and all the sand on the beach looks the same on this deserted island. So what we've done, though, is because you're a clever pirate, is you've written down kind of coordinates or compass, I don't know, instructions on using a compass to help you find where you put them.
Yeah.
So there isn't a big X on the beach, unfortunately, because everyone will know what it is, but you've got instructions and a compass on how to find it. So we're going to be using the microbit as a compass. So you'll have a real-world compass that'll help you in the game on Scratch to find your treasure.
Okay. This sounds good.
That's the plan. So, we'll start off. We need to make a pirate.
Okay.
So we'll need to make a new sprite.
Alrighty. One moment. I just need to do. There we go.
I'm going
Okay.
to paint it as well. I'm going to make it try and look a bit like a pirate. I'll show you
Hang
my
on.
terrible skills now, Dan, that you can try and recreate.
So I need to make a new sprite.
Yes, make a new
Okay.
sprite.
So have I got to? Oh no! So I need to try and draw one that looks like a pirate.
And top down, I'd go for. So I'm going to try and draw a pirate's hat by making like a triangle. Oh,
Okay.
God. It's going well so far.
What I just need to try and do is move you onto my other screen so that I can watch you as well.
Yeah,
If I do
sounds like a good
that,
idea.
hopefully that's not. Okay, yeah, I'm still sewing. Right, okay, I've got it. Oh no, okay. I'm not going to be doing a very good job of this, I can already tell you.
I'm not going to spend too much time on to design on the pirate.
No, it's probably not wise that I do the same.
I've got a pirate's hat, which is a black triangle, but essentially your trapezium, I think you might say.
Okay,
And then it's going to look like his arm's holding something, like a compass. I don't know.
oh boy. Okay. I just suddenly thought, Luke, if you want to look at the disaster that I am making, you could probably have a quick look. You could open up the live stream on YouTube and see my
Okay.
screen share. Oh no.
And I'm gonna. I think you want a pointy hat because then you know which direction the pirate is facing.
Yeah. Oh no. Okay. Well, this is a monstrosity. Okay, I can fill this. He's gonna have a red hat. No. Oh, I'm really putting myself to shame. I don't do drawing.
Neither do I mean, you're watching mine. You can probably tell. The actual game that I've made, it looks a lot better than this. But that'll do.
So he needs to be holding a compass?
Well, it doesn't have to be, but it just makes it look a bit better. But that's as much as I'll do for now.
Okay, yeah, there's... If
you squint enough and it looks vaguely like a pirate, I think we're done there.
I don't think this is actually even squintable to look like a pirate, I'm not gonna lie.
Okay, well, once you're happy...
We'll... Oh, yeesh. Yes. It's more of a stick, man. We'll call it a success.
Cool.
So if it's too big.
Next thing to do would be to rename the sprite. Call it Pirate or something, just so we have a good naming convention, so we know which sprite is which. Although you can probably tell by the terrible drawings that we've both done which one is the terrible-looking pirate.
Yeah.
Good. So the first thing we're going to do is program this pirate to move about. Now, on my screen, I don't know about yours, my pirate is way too big, and it'll make the game a bit too easy if he's that big, because the treasure can only be in a certain part of the screen, and he's taking up half of it, so it won't take him long. So we need to make him smaller by adapting the size of the sprite, which you can do under the screen on the right, once the pirate is selected. So there's a little size field.
Yeah, so let's have a look. Oh, okay, I've gone for 50, which I think is possibly... Not sure if that's a bit too small.
Well, I think 40 on mine, for reference for you, is about...
Oh, yeah, about 50 is fine for me then, I'd say.
Cool. Right, so we've got a pirate. I've moved him to the top corner, I don't know why. He can start wherever he wants. And then what we're going to do next is program him just so we can move him about with the arrow keys on the keyboard.
Mm-hmm.
So, first of all, so in Scratch, generally if we want to start a game, we usually click the green flag. So we need to find a block in events, because the clicking of the flag is an event. It's when something happens and then the game reacts to it. Or something reacts to it if we want them to. So we need to get a when green flag click block.
Lovely. I will zoom in so that everyone at home can see it a bit better. There we go.
Yeah. And one kind of common error lots of people make when I'm teaching Scratch is that they immediately put a background in, and then they find they're actually programming inside the background instead of the pirate. So it's always worth noting, whenever we're putting instructions in, that the sprite or the background, where we want to give instructions to, is highlighted. But it should be here because we haven't added a backdrop yet. Cool. So when green flag clicked, we want to make him maybe go to a certain part of the screen. And I think maybe top left is probably the best.
Yeah.
So if you just drag and drop your pirate to the top left of the screen.
And there we go.
So by putting him in that place, Scratch automatically registers its coordinates, and you can see that under the screen, the X and Y coordinates. So we can use that in blocks then without having to type it in ourselves.
There you go.
It's quite handy. So we need to find a block called go to, and then X and Y with the coordinates in that block. And that will be in motions, the blue one. And we also, depending on what we do at the end, we'll add this at the end. We'll go through it and do the whole thing without me jumping too far ahead. And now we want to give it instructions. So he's got a starting position. So if you kind of drag the pirate anywhere on the screen and then click the green flag, we should see now that he's going to go back to the position we put him in.
Let's have a go.
Cool.
Oh, wonderful. Yep, we are good.
There you go. And then the next thing to do is actually get the movement working. So we want that when we press the arrow keys, the pirate moves in each of the directions. So, because this is a different kind of event, instead of a green flag, this is pressing a key. Then we need to go to events again and find the when space key pressed.
Yeah, lovely.
But obviously, we want to change this because we don't want the space key to be controlling the directions, because you can't really control 4 directions with one key. So, you'll need to find, maybe we'll do the right arrow first.
Uh-huh.
So when the right arrow key is pressed, and then we want to make him point in the direction we want him to go, and then move a certain distance.
Okay.
So, let's go to motion, and in motion you can find a point in direction block.
Lovely.
And if you click on the number, so the field where you can put the number in there, the variable,
Yep.
it actually gives you a wheel so you can point in which direction you want. As it goes, the right arrow is already the correct one, so 90 means point to the right on the screen. So we can leave that as it is, but it's worth noting for the next ones. And then we can use the move 10 steps block, which is the first one in the motion blocks. And if you place that after the point direction, so now when we press the right arrow key, it points in the direction we want him to go, and then move 10 steps.
Lovely. Oh, look at him go.
Yeah. So, we want to do the same thing now, but for all of the other directions. So, you can copy and paste blocks. So, they're going to be the exact same instructions, but maybe with different values. So, if you want to copy and paste, you can right-click on the topmost block, so the when key pressed block. Click on duplicate, and then you can place the blocks anywhere else on the screen there.
Now, it's worth noting for people who are, particularly those who are part of my Techno Club on a Wednesday, that we are building up here a series of mini algorithms. Little mini algorithms for each one of the keys, so that when we're pressing that key, the character or our sprite is going to do something. And that's, as we've learned, an algorithm is a sequence of instructions that we use to tell the computer, in this case, what to do, or in this case, tell Scratch what to do. And so we're building up mini algorithms here, little teeny tiny algorithms.
Cool. So we need to do this for every direction. If I maybe do the left arrow next. Now, this time we don't want him to go right when we click the left arrow, so we need to make sure we change, first of all, the top block to be when left arrow key pressed, and the point in direction, instead of 90, which is to the right, if you click on the number and drag it all the way around to the other side, where it'll say minus 90, that'll make sure it points in the left direction. You can test out that you can move left and right now by pressing those two keys. Mine has a very long arm, and it's really unnerving. It's like a triangle with a very long arm, this pirate.
Yeah, it's okay. Because mine is more of a stick person, when I go to the left, it basically just puts him upside down. No.
There's a way to fix that. Maybe we can fix that later.
Yeah, we might have to fix that.
So, when left arrow key pressed, and so the other two, up and down. So we'll do the same thing for up. So we change the up arrow, change the key to the up arrow, and then change the direction to point upwards, which is 0. And we'll leave the 10 steps, so each time they're moving 10 steps. And then the same with the down arrow. Choose it down arrow, point downwards, which is 180 on Scratch, 180 degrees. I guess it's degrees, yeah, I would say degrees.
Yeah, I'm going to guess degrees.
Yeah, and then we've got, should have movement in all directions now when we press the arrow keys. So you can go up, down, left and right.
We sure can, but the configuration of my sprite is making it a challenge. But oh no, it's okay. We can try and rectify the issue at a later opportunity.
Yes, yeah. Okay, so we've got the pirate moving. Now we kind of need to have treasure that's hidden, because at the moment there's no treasure, and it's not a very good game if you have nothing to find. So what we want to do is, I think what we'll do next is make a background.
Okay.
Because the way we're going to do this is we're actually going to have a small little just circle, another sprite, which is just a tiny circle, and that is the same color as the background. So that when we place it on the background somewhere randomly, you don't know where it is. So we'll need to make a background first. So by clicking on the stage, and then we'll paint the backdrop, I think is probably the best idea.
Yeah.
And then you want to choose a color that, I don't know, looks roughly like sand, maybe?
Yeah. Oh, there we go. That's probably not too bad.
And that isn't so bright that it blinds you.
Yeah. Yeah.
And maybe make a big rectangle that goes bigger than the screen.
Oh, yeah.
And if you are very artistic, you can add in some trees or, I don't know, little bits of little rocks and so on. But you can't really do that too much because it might end up that the hidden dot that is going to be hidden in the background will actually appear on top of the rocks. So you'll be able to see where the treasure is hidden because of that. So we'll leave it as it is, just one single color for now. There are ways you can get around that, but we won't have time to go away everything like that today. Cool. So we should have a backdrop now, all the same color.
All done.
And then the next thing to do would be to make a new sprite. Well, it actually would be worth noting what the values of the color was that you used on the backdrop before we move on.
Let's have a look.
So that's mine.
15, 50, 100.
Okay. It used to be on the older version of Scratch that you could take the pen tool and copy the background that's there already, that's in the game, like on the screen. But now you can only use the pen tool for stuff that's in the actual editor for the backdrop or the. So they took out quite a few features I quite liked from Scratch 2 and when they made Scratch 3, which is a shame. Okay, and then we want to make a new sprite, paint a new sprite, and this is going to be our treasure sprite.
Whoops. Paint. Okay.
Oh, and actually, that has remembered the colour.
Oh, it has remembered the colour. There we go.
That's useful. And then we're just going to make a very small circle, or maybe just a kind of dot with the paintbrush right in the centre. It needs to be at least visible, but not too big.
It is very small.
I can't see mine now. Oh, now I can. If I zoom in enough, I can.
Yeah, it is there. I know it's there.
Maybe we'll make it slightly bigger than that. No, I've given it an outline now. That's not what I meant to do.
Oh no, now I've done... Oh no. Okay, right.
Maybe go roughly the size of the crosshair.
Yeah, that's what I was thinking.
Oh, I've zoomed out and the crosshair, it doesn't scale with the zooming. Okay, I'm quite happy with mine.
I'm satisfied.
If it doesn't work, we know what that might be the problem. So we'll revisit that.
Oh, we're able to increase how large the paintbrush tool is.
Yes, you are.
So
I should have mentioned that.
I will. Oh no! Now, if for some reason it's made Sprite 1 my sandy background.
Oh,
it's actually, I don't know if that's a bug or what, but it just tried to make Sprite 2. It just made it my sandy background, like the whole square that I've made.
Oh, that's interesting.
Yeah, I don't know what on earth happened there. Anyway, it is all good. The situation has been rectified.
Cool. So this new sprite now, we can name it Treasure, so we know what it is. It's the thing that the pirate's going to be looking for. And it's on the screen somewhere. I mean, if you want to know exactly where it is, if you click on the sprite Treasure, it will highlight it on the screen very briefly. So you know roughly where it is. Not that it makes a difference at the moment. Now, inside this sprite, we're going to give very different instructions because obviously we're not going to be controlling it with movement with the arrow keys. This sprite is going to, when we start the game, we want it to randomly appear in a position, or to randomly move to some position on the screen. So what we're going to do first is, again, we want this to happen when the green flag is clicked.
Okay.
We need to find that block again in events. So when we click the green flag and we start the game, the first thing this treasure sprite does is it picks somewhere random on the screen and goes there.
Mm-hmm.
So when the green flag is clicked, we are going to go to, so just like we did with the pirate initially, we want a go-to block. We don't have to place it anywhere yet, because instead of making it appear in the same place every time, this time we're going to make it appear in a random position on the screen. And so if you want to do anything with random numbers, we need to go to the operators, the green category, and find the block pick random.
Ah, yeah.
1
there
to 10.
It is. Pick random.
And you can drop this block into the coordinate blocks of the go-to. So and it fits inside there, and it'll eat it, is what I say, or swallow it. It swallows the block.
I like that.
You know that it's working then. And what you can do is right-click on that pick random green block, duplicate it, and then place the second one into the Y coordinate. So you need to be careful about where you put it, that you don't accidentally put it into the other pick random block. Otherwise you can end up doing very odd things. You'll pick a random number between a number and a random number.
And another random number.
Yes,
oh boy.
It's all a bit too random now. So, what we want here is kind of the range of the screen. So the values that the X coordinate can have and the values that the Y coordinate can have all over the screen. So the X coordinates, do you happen to know how big the screen is in the X direction?
Do you know, I'm not sure if I feel disgraced that I don't know, because I probably should.
Do you know, I think I've actually done it wrong on my... I have. So the example I'm going off actually is wrong. So when I made this a few years ago, I'm going to have to change that around.
Oh no.
So the X kind of values, the screen is slightly wider than it is tall.
Okay.
So the X can go between minus 240 and 240.
Mm-hmm.
And the Y coordinates can go between minus 180 and 180. So basically 0, 0 is right in the center of the screen, and then you can go negative in the X direction to go more left.
Yeah.
Or negative in the Y direction to go downwards, or positive goes up towards the right corner.
Mm-hmm.
Cool. So now when we click the green flag, and we won't be able to see it very well because obviously we can't see the treasure, that's the point. But if you click the green flag, then click on the treasure sprite, it should highlight where it is, and you can press it
definitely
again.
bouncing around.
Yeah. And you can see it's just picking a random position on the screen every time.
It is.
Cool. So now that we've done that, there's a couple of things. Maybe I'll let the errors happen, and then we'll find ways of fixing them if we come across them. I think that's probably the best thing to do here. Good. So we've got the pirate, we've got the treasure. And I think what we'll do first is, before we use the microbit, we'll just make sure the game works if we kind of use the space button. So when the pirate is actually touching the treasure and we press a button, then it'll say, congratulations, you've found the treasure, or yay, or something like that. Maybe we'll just get the character to say something in this instance. So we'll need to click back on the pirate, because the pirate's going to be the one in control of finding the treasure. And so we'll load up the instructions that we've already given the pirate on how to move. And I guess we're giving him instructions now on how to dig to find the treasure.
Yeah.
Okay, so what we need to do here is use an if statement. Because it might be the case that when we are digging, or we press space, we actually aren't in the right place and we didn't find the treasure. So we need to have an if statement, so that if we are touching the treasure, he says maybe, yay, I found the treasure. But if we're not touching the treasure, he says, no treasure here. And then what we could do as an extension is get the treasure to reset, so it's not in the position it was before and you have to start again, essentially.
Yeah.
So what we'll do is find an if statement. And because there's two different kind of actions or instructions that we do. One if we are touching the treasure, and a different one if we are not touching it. Then we need to use not just an if statement or an if block, but an if-else block. So these are all kind of, if you think of a program, usually a program has a start and an end and kind of different directions you can go in a program.
Mm-hmm.
And we call that like the flow. And there are certain things like if statements that decide which way we go. And that's why this category is called control. It kind of controls the flow of the program, which way you go in the program. And so we'll need to click on the control category.
There we go.
And inside there, so we don't want just an if block, we want an if-else block. So it's the 5th one in that category. And we have to decide where we're going to, or when this is going to check if we're touching the treasure. So at the moment, I've dragged this block in, but we need to have an event that triggers this. So for now, we'll just use a space when the space key is pressed. So similar to what we had before with the arrow keys. When the space key is pressed, and we call these they're called hat blocks because they look a bit like baseball caps and they go at the top of the algorithm, of these little algorithms we're making. So you can't wear hats at your feet is what I always say, so the hat block always has to go on the top. And the rest are called stack blocks. They kind of stack underneath like jigsaws. So, when the space key is pressed, we've got an if-else block. So it's a weird looking block. It's kind of got two gaps in it, but also a kind of gap in between the if and the then, like a diamond-shaped block, I'd say it was. Now this is where we put something really important called a condition. So we're just checking if some condition is true, then we can do something. But if it's not true, else we'll do something else.
Yeah.
So if we go to operators, that's where you'll find the kind of diamond-shaped blocks we need. And I forgot what we're checking for. Oh no, we're checking to see if the pirate is touching the treasure.
Yeah,
so there are some diamond-shaped blocks in operators that you can fit in there, but the one we're looking for isn't actually in there. It is in the sensing category. Yeah, that's it. And it's the first one there. If you're touching, and it says touching mouse pointer, but we don't want that because otherwise it'll check if it's touching where the mouse is on the screen. So we're going to click on the drop down arrow, and there's three options. Well, it should be anyway. One is edge, so that's just checking if it's touching the edge of the screen, which we don't want, and treasure, which is our newest sprite.
There we go.
So we drag that in again, and it swallows it up. And now we've got the condition. But we haven't told it what to do if it's true or if it's false. So we've got two gaps where we have to fill in that information for the game. So if it's touching the treasure, let's just get the pirate to say yay or something like this.
There we go. So we'll get that from looks.
And we'll do it for a couple of seconds, just because. I don't know, just because. So he's not just saying yay forever and his voice goes. Okay, so say yay for 2 seconds is what we'll do. And if he hasn't found the treasure, maybe he'll say boo or I'm sad or something like this. So we can duplicate the say block and place it in the else. So it's if it's true, then do the first thing. So say yay. Else, so if it's not true, what's he going to do if he doesn't find the treasure? I'm going to put I'm sad with a sad looking face.
There we go.
Okay, so just for testing purposes to make sure this part is working, so we don't go on and finish the whole game and then realize it wasn't working anyway. If we click the green flag, click on the treasure sprite underneath the screen so we know where it is on your screen, and then kind of try to move the pirate so it's touching it.
It is working successfully.
Great. So one error I get when I touch this treasure now is the treasure actually appears on top of my pirate. Do you see that error as well? It depends on how big your treasure was.
Hang on, let me have a look. I can't. Oh, yes, it does.
Good. So for now, it's actually quite nice for now because we're testing it. We know that we're touching it.
Yeah, exactly.
And now the instructions we just gave the pirate were: if we press the space key and we're touching the treasure, the pirate is touching the treasure, he should say yay. And he does. And if we're not touching the treasure, if we move away from it,
he says, I'm sad.
He does. Great. So we know it's working. Now we could fix that little kind of bug where it appears on top, but I think we'll leave that till last, just so we can do more testing, which makes it easier for us. Great. So we've got it working with pressing the space key. And now is when we're going to get the microbit stuff in here.
Oh, now this is where it gets exciting.
Yes. So we know it's working without the microbits, but now we've got to get a microbit as a compass, so we can find out where it is without cheating and clicking on the treasure sprite. So, what we're going to do now is the easiest way I found of doing this, because I spent quite a bit of time making this game before, is we're going to have an invisible pointer. And I'm calling it a pointer because it's always going to be pointing towards the treasure. So the player doesn't know it's there, but in the background, it's constantly pointing towards the treasure and sending information to the microbit about what to show on the screen.
Okay.
So what we want to do is make a new sprite. And this one actually, now I can't remember. I don't think you actually need to give it any sort of costume.
We can just leave it as a completely blank sprite.
Just an invisible sprite. But it has a kind of a position. Even though it's invisible and there's nothing in it, it still has a position that we can link to and use that in order to tell the microbit which direction to point in. So we can just make a completely blank sprite. So just click paint and then just not add anything. I mean, you could add something, but it doesn't really make a difference if you had something or not. It's not going to affect anything. And I'm going to name this pointer, just so I know what it's doing. So it's pointing towards the treasure. Okay, and now we've got quite a substantial bit of code to put in to get this microbit to do what we want, to make it to be a compass, essentially. And there's lots of angles. So I hope you are good at your angles, Dan, because this is going to get a bit chaotic.
Angles, lasted angles, probably GCSE maths, maybe.
Okay.
I did it in sixth form for something.
That's good. Hopefully it won't get as complicated as sixth form angles, but we'll see.
Oh, rest assured, this is not sixth form A level angles.
Oh, okay.
Oh no. Wouldn't have gotten that far.
Okay, so what we're going to be doing is getting this pointer to always go to where the pirate currently is. Okay, so it's constantly, as the game is being played, it's constantly going to the pirate's location. So it's basically always on top of the pirate.
Okay.
So we'll need that to start when we start the game. So when the green flag is clicked. So if you drag that into, and make sure you're in the pointer character, or sprite, sorry. And because we want something to be always happening here, we want to add a loop. So the concept is called iteration. So to do something more than once, over and over again, essentially. And where we would find that is also in control. Because again, it's controlling the flow of the program and how it's happening. So in control, you'll find a forever block. And that obviously does what it says on the tin. You can see a little arrow that points kind of back up. It says once you've reached the bottom, go back to the top and start again. And we always want this to be going to where the pirate is. So in motion, there's a go to block, and it says go to random position. So we place that in the forever loop. Now, if we left it like this, it wouldn't be a very helpful compass, because it would be going haywire all over the place and you wouldn't get any information out of it.
It would look a little bit like Captain Jack Sparrow's compass.
It would, yes. It would be like if you stood in a very strong magnetic field that was just kind of affecting your compass. And we need to change this to say go to pirate, because we always want this to be where the pirate is. So every time, pretty much like thousands of times a second here, this will be going to where the pirate is. So it shouldn't ever get left behind by the pirate. Otherwise it wouldn't work very well. And we always want this to point towards the treasure. So that's another thing we need to add. So it's going to move to where the pirate is and point to the treasure.
Point to the treasure, okay.
So point towards is also in motion. But we need to change mouse pointer to treasure. So we've got its position and what it's pointing at, and it's constantly updating that as we're playing. And this is where the tricky part comes in. And this is not very nice code.
Okay.
I mean, it's the best you can do in Scratch, and this is how it should be done. But it's going to take a bit of effort to get this to work properly.
Okay.
So let's go with what we want to happen here is if we are stood on the treasure, so we'll start with that. If we're stood on the treasure or very near to it, we want the microbit to show on the screen an X, because X marks the spot.
Okay.
So we're going to need an if-else here, because if they're not standing on it, we're going to do something different.
Okay.
So we'll need an if-else. And this is going within the forever loop.
Righty.
After the first two blocks we put in. And the condition here, we're going to say if it's maybe within 10 pixels of the treasure, because we might be very close to it, but just maybe the pirate isn't quite touching it, so it's like in between his hat and his arm kind of idea.
Yeah.
I don't know what your pirate looks like, but that could happen with mine. So we're going to give it a small radius that you can be within. That'll still work.
Right.
So to do that, we need to say if the distance to the treasure is less than a certain distance. And so we need to get a less than block from the green operators, that's it. And distance 2, so that measures the distance between two sprites, is in sensing. So you can sense the distance between two sprites. So we're in the pointer, and we're saying the distance between the pointer and the treasure. Okay, I'm going to put that in the left-hand side of this less than block, the green block. And we can play around with the value in here, but I've used 10 before, and that seems to work okay.
Okay.
That's again another point to keep in mind in case something goes wrong when we're trying to do this. We can come back to that and look at that value. And here's where the exciting bit comes in. So we're actually using the microbit.
Oh, exciting.
So when we linked the microbit earlier, you might notice on the left in the blocks, it added a microbit category.
It did?
Yes. So if you click on that, you'll see all the possible kind of functions that the microbit can do through Scratch. And we want it to display on the screen. So if you drag the display block,
oh, there we go. Yeah.
and then click the drop down arrow, we don't want a heart. We could have a heart, I guess, but we'll just kind of load this up, and you can click clear to make all the things off, or you can make them all on, whatever's easiest.
Yeah.
It's a nice little tool there. And I'm just going to make an X that goes right across the whole thing. So it displays an X on the screen. Okay, so that's the easy one. If we're standing on it, the microbit now will show an X. But we need to say, it's not a very good compass if it only tells us when we're stood on it, and it doesn't give us any indication of how to reach the treasure. So we want to have an arrow for every kind of direction it could be in.
Okay.
Now, because there's only 10 minutes left, I don't know whether to keep this just 4 directions. I think it's probably a better idea.
Okay. It'll be.
Right.
I think four would be reasonable, and then
people can kind of extend this.
yeah, exactly.
Yeah, and it keeps the maths a bit easier, hopefully. Although I haven't prepared this maths. I had the other ones prepared, but we'll see how it goes.
Well, as I was saying to you, the avid Technolive users are aware of Jack and I's ability to do maths, and it is maybe not ideal. So a simple maths is good.
Yes. So we'll go with, there's 4 directions then we need to point.
Mm-hmm.
Either up, right, down, or left. So we'll need 4 possible outcomes, or I want to say branches, inside this else branch.
Okay.
So we'll need to use many if-elses here, which is where it gets a bit messy in Scratch, because there's no real nice way of using...
There's no else if.
Yes. And that's one of the downsides to Scratch, but I guess it kind of makes you appreciate how it's working a bit more. I don't know. So I've put an if-else inside the else.
Good.
And then what we need to do is we need to give 2 values, so 2 angles, that if the direction is between those 2 angles, it displays the arrow that we want. So essentially, if it's above us, we want it to display an up arrow.
Mm-hmm.
So because we want to give 2 directions or 2 angles, we're going to use a Boolean operator called AND. So in operators, it's an AND block, and you drag that in as the condition for the if. But then we also need to do something else, which is check the direction, and is it more or less than a certain value for the angle. Okay.
Okay.
So I'll just put the more than goes in the left side of the AND. Okay, and in the right side, we're going to say less than. I hope this works.
And by more than, we don't mean more than home insurance.
No, we don't.
We do not mean more than home insurance. Other insurers are available, not sponsored. This is...
That's thrown me now. Okay, yeah. Where was I going with this?
We have the more than and the less than.
Yes. Okay, and we want to check the direction. So direction is just whatever direction that this pointer is currently pointing in.
Mm-hmm.
And if you remember, it's always pointing towards the treasure, which is what we want.
Mm-hmm.
So we use the direction block, which is in motion, quite near the bottom, and drag it into both of those, so that we've got direction is more than some value, which is currently 50, and direction is less than another value.
Mm-hmm.
Okay. So let's think about this. We want it to, if it's pointing, this one's going to be pointing upwards. Okay, so we'll maybe add in the microbit block for display.
Display, and make it an up arrow.
Yeah. So a nice arrow pointing upwards. That'll just help remind us which direction we're going with when we get trying to work out which angles we need to put in here. Now, I have sent you down a link to another Scratch thing, a tool really, to help me kind of work out what angles I need to use here.
Absolutely, and I've got it open.
So if you open that up, you see it's a Scratch program I've made that'll help us work this out. So on this program, if you click on the 4 sectors button,
oh, look at that!
It actually overlays the angles. I don't know if you're currently in maths angles or Scratch angles.
I am in Scratch angles.
Great, so that's what we want. So this is slightly different to normal angles where it goes from 0 to 360 around in a circle. Where Scratch goes from 0 to 90 to 180 and then starts at minus 180 and goes in the negative numbers back up to 0.
There we are.
So this is really going to help us with what numbers we need to put in here. So for north, which is when the arrow points up, it says we need between minus 45 and 45. Okay, so in our program then we can go back, and so it needs to be more than minus 45.
Lovely.
But less than 45.
45. There we go.
Okay, and now we need to try and do the same thing for the other 4. So in the next one's going to be in the else, and the shortcut to do this, if we copy or duplicate the if that we just did,
and then we can change the arrow.
Yeah.
Wonderful.
Place that into the else that was left blank at the moment. And you see it gets a bit crazy with how many we're going to do this, especially if we had more than just the 4 arrows. That's why we're keeping it simple, or as simple as possible. And now this one we can point maybe right.
Yep.
So
Sounds
we'll
good.
change the arrow around to point right. I'm sure there's a way you can change these arrows without actually changing too many of the dots, but I haven't worked out the most efficient way. And then if we look at the compass, we'll see it's got to be more than 45, but less than
90.
not 90.
Not 90. Wait.
Because we want it to be like within the range either side of east. So we need to be more than 45 and less than 135.
135. There we go.
Yeah, so it's kind of 45 degrees either side.
Yes, I'm seeing that now. Okay.
Yeah. So more than 45, less than 135. And we repeat this again for down. So we drag the if else into the else section that was there previously. Change it to a down arrow. So this one's going to be more than 135. No, hang on. Is this where it gets complicated?
Yeah. Oh, hang on. It needs to be
more than 135, but less than minus 135.
135. Yeah. So more than 135, less than minus 135. And then for the last one, are we just using a normal if, or are we going if else again?
I guess because of the way we've put this together, it should work by just putting the other kind of display in the else. Because the way we built it up, it's going to check each one in turn, and then if it wasn't the first three we put,
yes, good shout.
But I'm now questioning if this logic is going to work for us. So it has to be more than 135, but we can't have it to be more than 135 and less than minus 135. So I think what we need here is an or. Does that make sense? It has to be either more than 135 or
less
than minus 135, because it can't be both. Because if you've got a value of 170, that's more than 135, but it's not less than minus 135. So I think we need an or here. I'm starting to question that program I made a couple of years ago, whether it actually works now. I thought it did. So we need to actually change the and for an or.
There we go.
So let me quickly do that on mine. I'm glad we didn't try it with all the other angles. It would have gotten very complicated. So I wanted more than 135 or less than minus 135. And then if it's not any of those, hopefully it'll just display the other option, which is an arrow to the left.
I've put my arrows the wrong way around here. There we go.
There we go. So we shall see if this works, I guess. So now if you press the green flag, your microbit.
I've got arrows.
Good. And moving around the screen, it should end up moving the arrows and changing the arrows, pointing towards the treasure.
Oh yeah. It is.
Yep.
I'm
and then
sad.
Oh, were you not touching the treasure?
It's telling me to go right then left, and I click left and it tells me to go right, and then it says I'm sad.
Maybe try do you know we said the distance to treasure?
Change the distance to treasure to being
a bigger number there. If the distance to treasure is less than
I've tried 20. Right.
Yeah, it's working for me with the 10, so maybe I had a bigger treasure radius.
Now it's just displaying an X.
So if it's displaying an X, that means you're you're on the spot.
Oh,
But does
well,
it mean you're touching
apparently,
it?
but it says I'm sad, so...
Oh no, wait. That changing
Oh,
them I wouldn't fix it, would it? Because
yeah,
that's...
wait, oh, hang on, I've got it.
Oh, okay. I'd say probably make the size of your treasure bigger.
Small... Yeah, so let's enhance treasure size. Let's double it.
Yeah, and changing the distance, that value wouldn't have fixed it. It would have just made it the X appear when you're just standing near it but not actually touching it. So
Yeah, okay, I'm going again. Here we go. Right, I'm off. Up. Go up. Go right. Up. Oh, I'm there.
and if you press space,
Oh, I'm sad again.
oh no,
It's because I wasn't touching it. I am now.
oh,
It's
there you
it's because of the nature of my stick man. The legs are so thin that I was on it, but because his leg wasn't quite touching it, it said I wasn't there. But I am now, and I've got a yay.
go. That makes sense. So maybe we need a man with more, I don't know,
Sustenance.
more about him. Yeah.
Yeah.
Cool. So just very small things to add to make this a bit better then, because we've got it working as we wanted it to. So my treasure dot is still appearing above my pirate, so I know on the ground playing the game without even looking at the microbit if I'm touching it. So what we can do there is in the treasure sprite, what we should do before it picks a random position, we should make it go to the back layer.
Okay.
So in looks, you can find towards the bottom of the looks category, it says go to front layer, and you can change that to go to back layer. And that means that it'll always appear underneath the pirate, not on top. So you won't be able to see it. So now it's more of a realistic game. And I guess the last thing we can do to make this slightly better is, instead of using the space bar, we could use one of the buttons on the microbit to actually dig for the treasure.
Oh, okay, yeah, good.
So if we go back to the pirate, then the first, the block we had where we had when the space key is pressed, we can just simply take that top block off by dragging off the if from it, then swapping it out for in the microbit category. You could use when the A button is pressed or when the B button is pressed. You could even have a different input with it, which is when moved or when shaken or when jumped.
Oh, I've pressed A on my microbit and had success.
There we go. So there's various different things you can do with microbits, and I think quickly before we end, it might be worth showing a different kind of game that I've made using a microbit.
Oh yeah, the racer.
Yes, so this is the most exciting game I've made, I think, with a microbit in Scratch.
There we go.
So you can see on that game, I made it 2-player so that anyone could play just with the keys and the Z and X kind of buttons. But also, you can use the microbit as a controller itself if you're playing the 2-player version. I don't know if you want to try that out, Dan.
I am giving it a go.
So I think you'll have to choose the 2-player one, as far as I know. I can't remember. Maybe if you click 1 player, does it?
Oh, it does say I can choose.
Oh, that's good. I did put that in. It was an extra feature I added.
Right. Oh, hang on. I'm gonna try again. 1 player. Use microbit. My microbit is. Oh, do you think I'll need to see inside?
Oh yes, you will, because you need to.
Yeah, because I need to connect the microbit there, don't I?
Yeah, and you'll probably have to shut down the other script because it'll still be connected to the microbit.
I will do that. Leave script. Microbit racer. Okay, connect. There we go. Go to editor. I'll make it big. Okay, here we go.
Okay, so did it
give
you instructions?
Oh, it does, and I am moving.
So you can use the microbit tilt left and right of the microbit to actually direct it. It's quite difficult to get used to.
Oh, it's quite a lot of fun though.
It is. And the A button, I think I've programmed to make it faster or slower. I can't remember.
It just kind of moves along at and speed.
Yes, but you can. The more you press it, it kind of
Oh
increases
my!
the speed, and
Oh, I
then
don't need to hold it down.
no, so you can every time you press it, it increases the
Oh,
speed by a
look at
certain
me
amount.
go! Oh, this is. Oh, and then B slows me down. Oh, this is wonderful. I'm
Yep.
going at it. I'm moving.
So there's lots of cool features in this. So I quite like the bridge aspect of it. That you can go underneath and over a bridge.
Mhm.
So that was quite tricky to program. So what I've done is kind of made checkpoints, because I wanted it if you crashed that you
You
got
get
reset.
Yeah.
Because I didn't want to have to put reversing in. It was easier to just reset if you crash. But there's hidden checkpoints along there. So there's just basically sprites that are the same color as the road, and when you pass over them, it registers that as
It
a
does.
variable, and then it takes you back if you crashed to that position. And so the checkpoint just before the bridge, the special checkpoints, when you touch them, it makes the car go to the front layer. And then when you go underneath it, it makes it go to the back layer, and that road is like a sprite that's on top of the background.
Makes sense.
Yeah, so it's pretty cool. I even had to make a separate bonnet for the car. It's a different sprite, just the bonnet, so that if your car clips a wall with the back, it doesn't reset you as a crash, because that was happening a few times. So it's only if the bonnet hits the wall do you get reset. And after 3 laps in this, it'll also give you a it'll give you your times, and it'll say if you're in the high scores or not. Lots of crashing going on. And the other thing I was going to say is I quite like if you touch the grass, the pen tool gets used and it draws brown.
I've seen that, and I'm
marks.
quite impressed. I wondered what that was.
So that's like a game people could make exactly the same kind of code. Obviously, it's more difficult, and I've added loads of features. But a really simple driving game wouldn't be too hard to make with this micro.
No, exactly. Well, there we go. So that, I think, concludes this week's Technolive, as I do a terrible job of driving around Luke's racetrack. So, thank you very much indeed, Luke, for joining us today on your first ever Technolive. Hopefully we'll have you back again in the future.
Yes.
So, in terms of the usual admin bits, remember that the Techno Clubs are still ongoing. We are still hosting those Mondays, Wednesdays and Fridays. So if anyone is interested, we are currently quite busy. There are quite a few people signed up, so you will have to go onto a waiting list, but remember that they are still running. And feel free to have a look at the Technocamp's website to find that out. A bit more about those out. We are back again next week with another Technolive. Jack and I are here. Don't know what we're doing yet. I think Jack and I will need to have a bit of a chat about that sometime soon, about our future live streams. But we will be back next Thursday at 4:30 as always. But as Jack would say, in any case, I think that concludes this week's Techno live stream. So thank you all very much again, and we will see you next week.